It's not the best scenario having this on a Monday. I can't stand having quizzes and tests on a Monday. Okay, because I don't know what goes on between now and the weekend and Monday. But it's forced my hand to do it because, again, if I move it to Tuesday, here's what I'm facing with Tuesday. I don't know if you're going to be here or not with this whole Regents exam and global. If you are here, you want to go from a 3-hour test to another unit test? I don't think so. Okay, so even if you are here, okay, great, but still, what am I going to get out of it when you guys have a 3-hour global exam followed by our unit test? All right, and this is the last huge grade of the fourth quarter. All right, last huge grade of the fourth quarter. I'm just going to let you know what's on it. I'm going to let you know where you can go, but I'm not going to say, okay, go do what you want. We're going to go Regents review. Okay, so this is going to really be on you this weekend, or if you want to come after school today to review. It's only going to be 37 points, 10 questions. Half of them are multiple choice. It's all volume and surface area. Please, please, please keep in mind where your volume formulas are. They're all on the formula sheet. There is not one volume formula that is not given to you. But on the other hand, what about surface area? There are none that are given to you for surface area. So I just wanted to quickly go over a couple lateral areas that you're going to have to be responsible for. And also, I'll go over another surface area one that you should be familiar with. First one's a cone lateral area. And I'm only doing this because I saw what happened to some of you on the quiz. Cone lateral area, pi r L. The L for slant height. Yes. Remember how a cone works? Not doing this. Actually, I'm not doing that any justice. Is this my slant height right here? No, that's the height. That's the altitude. Here's the height. Here's the radius. Here is your slant height. You can do Pythagorean theorem to figure out any of the three values. Cylinder. Pi dh. D for diameter, height of the cylinder, pi dh. If you want to find the surface area of a cone, what do I add on to this? Which is pi r squared. If you want to find the surface area of a cylinder, what do you add on to this? 2 pi r squared. Now that I think of it, the only other one I'm going to put up here, that's not on your formula sheet, surface area of a sphere. Surface area of a sphere? 4 circles. 4 circles. And if you have to take a surface area of a hemisphere, okay, divide it by 2, but also add in the circle on the bottom. So I think did we go over how it was 3 pi r squared or no? Did we? Okay, here you go. Ready? So surface area of a hemi here. Hemisphere. You have 4 pi r squared, right? Cut that in half and add what on to it? Pi r squared. Ready? What's this simplify to? 2 pi r squared plus another pi r squared. So if you want to, I don't know which way you want to remember it. Either way, though. Okay. Volume, you do not need to worry about what's covered up. Okay, because we are going to have a problem just like it was, I forget, what was the figure on your quiz? Where it was right on, the 2 right on top of each other. Well, there's going to be one of the, you know what I'm talking about. There's going to be one. What was it? No, that's wrong. No, the quiz. No, you're on the test from last unit. The quiz from the, what's on the back there, Emma? Okay, one of the, well, what I'm just trying to show you, one of those figures. You're going to have to do surface area and volume for me on that same figure. Okay? There will be one density problem, and I'm going to come a little strong with the density problem. It's very, you can almost consider it just like the snow cone example from the other night. I'm not guaranteeing that you have to change units. I'll let you guys decide that for yourself when you read the problem. Okay, but it'll be a pretty strong density question. If it is, I'm not going to have you convert. How about that? Rest assured this weekend. All right, go easy on yourself. It's not you'll not have to convert a darn thing, but you're going to have to go. Got to find this, define this, define this at the end. Okay. But no, everything will be in all the units you need, so rest easy. And then last thing I just got to talk about is what we went over yesterday, where the similarity ratio squared is equal to surface area. And the similarity ratio cubed is equal to the volume. And I'll let you guys know because I want you to be prepared for it. And if you want to prepare for it, go for it. The question I have on there is very much like the two questions we did yesterday in the notes where I gave you surface area, volume of one, find the volume of the other. Okay? So something similar to that. No pun intended. All right. Anything else you want to ask here? If not, I'm going to go right to the region stuff here. You guys see where the review problems are on the back of your packet, page 32. There's only 4 there. Answers and work are on the following pages after your formula sheet, and then there's a couple textbook questions to try. I didn't put a ton on there because there's not much there. And the final thing I'll let you know, I know people come in and say, hey, can you give me extra one of these problems? I have exhausted all my density problems. The only one I have not given you is the one that'll be on the quiz. Okay, I have given you 2 days worth of density stuff. That's all the problems I have. Okay. Anything else? I do have more, but it's way above what I'm going to expect of you on Monday. So I'll give them to you if you want, but it's a little bit above what I'll be asking on Monday. Any more questions, comments, concerns going into Monday? And yes, I will be here after school if you want to go over anything. All good? All right, here we go then. We got the exam from this week. The Regents exam from this week. I'm sure some of you are going to be so happy with the problem I'm about to review with you going in last day of the week here on a Friday. We're in the Regents test I've given you, I believe, January 2017, the one you got on Monday. What are you trying to figure out which one I'm going to pick? Go ahead, you let me know. 30. It's going to be approved. Should we try to find a proof because we haven't done one in a while, Heaven? Is that what you're saying? All right, let's go. 35. That's the one I chose. Just to update you as well, because they have changed the exam in 2018. Most of the exams we have been doing, there's been 2 part 4 questions. Usually it's a proof and then a huge like density SOHCAHTOA type problem. They will only put one part 4 now, starting this year. All right, and it will be a proof. Okay, it will be a proof. The density stuff, that's not going away. It might be in like part 3, but there's only going to be 1 part 4 question worth 6 points, and it's most likely going to be some type of proof. Okay, so just be aware of that. You may be doing a lot and say, oh, I'm going to be prepared for 2 questions in part 4, only 1 question in part 4, and it's going to be a proof. What type of proof? I have no idea, guys. I do not see the exam until you see it. But whatever it is, I'm sure you'll be prepared for it. So might be a statements reasons like we're about to do. Maybe one of those coordinate geometry where you graph it and prove it's a figure using slope, distance, midpoint.
How many review sessions are you going to have?
Quite a bit. Because it'll be starting that Tuesday of exams. I got to figure out when I'm available, but I can tell you that Saturday before I'll be here during the day, like a 12 to 3 type during the day, the Saturday before, and I'll probably be here Monday night because your exam's on Tuesday morning. But I probably won't be here Tuesday before because it starts at 8. So, but I will be here Monday night most likely. And it'll just be geometry. That's it. You don't have to worry about my algebra kids coming in and reviewing because they'll be done with their exam.
What time should we be there?
That's up to you. We'll probably let you in about 10 of 8. So it's up to you when you want to get there. I'll talk more about it as it comes up. All right, you guys ready? I look at the proof statement and I see AE congruent to CF. My mind automatically goes to CPCTC. But before I can use CPCTC, what's got to happen? Got to prove a pair of triangles congruent. So my mind then goes, okay, what triangles contain AE and CF? And I can only really see 2 of them. And that's AED and CFB. I'm not saying this is the only way to do it. This is just the first way I've seen. I've thought about it. So can we get those triangles congruent? First thing, be careful. What type of figure is ABCD in the Gibbons? That means you have no properties, guys. No properties. It's a quadrilateral only. No properties exist that you can use. So let me go to the Gibbons. AB and CD are congruent, and they're also parallel. Did I just turn that into something? What did I just turn the quadrilateral into? Yeah, a parallelogram. Some of you might be wondering why. ABCD is a parallelogram. Anybody know why? I know the markings, but Mike, how do I say that?
One quadrilateral with one pair of congruent and parallel sides. Proves a parallel.
Close. You're just missing one key word. What about those sides? They have to be opposite each other. Yes, that's our special case we talked about back in the day. A special case. One pair of opposite sides that are congruent and parallel. Sides congruent and parallel means I have a parallelogram. Yes. It's got to be the same pair. Got to be the same pair. One pair can't be, hey, I can't have this. This is not a parallelogram. No go. It's got to be the same pair. Same pair. Perfect. Now that I know it's a parallelogram, let's throw around some properties that may help us out here. Here we go. Heaven. There we go. Got a pair of sides. AD congruent to CB. Because I know a parallelogram implies, what property did Heaven just use? Opposite sides congruent. All right. She got us a pair of sides. Thank you. Where else can I go? And you don't need to use a parallelogram property either if you want to go somewhere else. You don't need to use it. Anywhere else here? Hi, Kate. I'm doing well, thanks. What's that? I don't need to say angles, but I can say those angles are not yet. Right angles first. Yep. Because DE and BF are both perpendicular diagonal AC, those are right angles. Thank you. So angle AED and angle CFB are right angles. Remember why, Kate? It's like you never left, right? All right, nice. Go anywhere else here? Hi, Emma. I'm going to. Let me just repeat what Emma said. She's like, hey, how about those alternate interiors you got up there? They're only alternate interiors. They're not congruent yet. What's going to make them congruent? Here you go. Name the angles you're talking about, Emma. This angle and... yeah. They are alternate interior. Anybody want to know why they're not congruent yet? I didn't tell you the lines were parallel yet, but are they? Okay, so let's put it in first. I got DA parallel to BC. Why are they parallel then? It's a parallelogram property. Yep, perfect. Opposite sides parallel. Now you can say those alternate interiors are congruent, but you got to have the parallel lines first. Got to have the parallel lines. Not as smooth as I thought that was going to be. I thought it was going to be a little bit smoother on there and I could glide down easily, but nope. Parallel lines imply alternate interior. Oh, got a pair of angles. But you need 3 pair, right? I only have a pair of sides and a pair of angles. Where's my third pair? Emily? Yeah, I said they're right angles, but I didn't mention that they're congruent yet. Thank you. There we go. All right angles are congruent. All right, so up here I see 2 pairs of angles and a side, and there's 2 methods I could use, angle, side, angle, or angle, angle, side. You guys look at the diagram, figure out if that side we marked congruent is in between the 2 angles or not. So triangle DEA, got to make sure the right order, right? DEA, BFC. Was that side in the middle or not? Nope. So it's going to be angle, angle, side, and then you can finish it off. And I'll tell you, I take this proof over a lot of other types. If this was our part 4 proof, something like this, where you just prove a pair of triangles congruent to say CPCTC, I didn't think that was that bad for this, for the part 4 type proof.
Do you know if there's any indirect in any of the packets?
Well, let me put it this way. Have I ever seen one since this exam came out? No. But I had never seen halves of equal quantities being used until 2 years ago. So just because it hasn't never been used in the last 6 exams doesn't mean it couldn't be fair game in this one. Questions? All right, what's the next one I'm going to do then?
21.
That's not a multiple choice.
It has to be multiple.
No, it's not going to be. I can tell you the next one I have up here is not multiple choice.
36.
What?
30, 32. 30.
27. Jack is 27.
30.
Another proof?
It's not a proof.
Oh, I read that wrong. That's a proof.
Excuse me?
Ooh. Okay, okay. Is it easy? Okay. AXC. Can you help me get to it? One fact you'd like to display, Cam.
In a isosceles triangle, the sides across from the angles I don't know how to word it. The angle EAF is going to be congruent to DCF.
Yep. So that's also 50. All right. Still listening to more people here. Amy? Yep. Got it. And then we ready to finish this off now? Define angle AXC. What are you using to find AXC? That triangle, right? There's 180 degrees in it, minus the 225s we already have. So that'll end up being 130 degrees. Okay. Nice job. I also picked this one because I wanted to see if anybody could remember, and this is why we review, so if you don't, that's fine. Anybody could give me the name of point X.
In center.
In center, where the angle bisectors intersect. Yes, that's called the in center.
What's
Yeah.
circumcenter?
Circumcenter is where the perpendicular bisectors intersect. Centroid is the medians. Yes. And that's the 2-to-1 rule we'll have to review. Yeah. Yep, a lot to review, which is fine. No big deal. It wasn't the best of units, but that just means we got to review it even more. 28, everybody. All right, here we go. Arc AC and arc BC are congruent. Thank you very much. Got some secant and a tangent. Arc BC is 152. What's the measure of angle D? All right. This just comes down to, do I remember the rule or not? And hopefully by the 19th, we'll remember the rule. You're finding an angle. You're not finding any lengths now. You're finding angle D. And where is angle D located? Outside the circle. So there's only one rule for any angle that's located outside the circle. It's a half of something.
It's a half of the arc that they connect to.
No. It's half of AC minus AB.
You're right.
Never mind. Just listening. Go ahead.
One half.
Half of what arcs here?
AC minus AB.
Yep. All right, I need a little help here. Arc AC will be $1.52 minus.
How do you get that?
They told me the arcs were congruent in the givens. Okay. And then what about AB? I was not given that one.
Subtract 208 from 152.
Wha-
Because arc BC is 152, which
Yep.
means BAC has to be 208, and
Yeah.
you subtract 208 from 152. 152 plus 1. You could do it either way.
Okay.
Yes, it is, because
If
the
the answer's
whole
50.
No. People think you're saying that arc AB is 208. It's not 208. What you're saying is the rest of this arc BAC is 208. That's what Cam is saying, I believe, correct?
Yeah.
So 208 minus 152. Yep. What do we get for that arc? 56. Yep. So I take half of 152 minus 56, and that'll end up giving me 48 degrees. Okay, so just, I know there's going to be a lot of circle facts to remember, but just start reviewing it now. I think it'll be better.
Yeah, good. It's hard.
24, everybody. Good little review for Monday coming up.
hey, that's one of the ones I get.
Okay. Bless you. Okay, so it looks like volume of a cone here on the formula sheet, since it is a volume formula.
Wait, why does it say like maximum diameter?
What's that? That's the largest diameter. So when the cup is filled to half its height, what is the volume of the water? I guess just that's as far as you can go with it. Maximum diameter. So I don't know, again, that's a good question.
Is it like at the largest?
Yeah, but it's
Oh, okay, that's because if you think about a cone like this, if I take this cross section right here, that diameter is going to be a lot smaller than here, so that's why they're saying maximum. So I know it's definitely the largest. This has got to be the 3 inches here. What? We good? 1/3, yeah, half its height, everybody, not the height, half its height. So 1.5 squared, I'm not going to plug in 4, I'll plug in 2.
Have we had this problem?
No. Cup is filled to half its height. Yep. So what's the volume of the water if I fill it to half its height?
4.7.
4 point. If you plug 4 in, is the answer there?
No.
Oh, wow, I'm surprised.
It's like foreign.
Okay. That's what we all got, Will. Thanks. You good? Always the confirmation back there.
Wait, we didn't get that. Wait, he said he got 14.1. We got 4.7.
That's not the answer. It's 4.7.
He got it wrong.
Well, hold on.
He got 14.
All right. Never mind. Sorry.
We tried to roast him, but
We tried to be smooth, but you failed.
It just
We all right?
Mistakes were
What
made.
we like to see.
Let's go to 21. Okay, and what's the area? What do I call that area of the shaded? We actually have a name for it. That's a sector. Yep, that's a sector right here. 2 sectors, but we're really concerned about the shaded one here. All right, so formula.
A measure of arc.
Okay, time out. Let's not go any further. Measure, what is the measure in degrees of that major arc right there?
300
360 minus 60. All right, rest of the formula.
over 360 times 6 pi.
Look at, is it inside or on the inside the circle or on the circle here, the shaded region? Inside, so what do we must be talking about then? Not circumference, but if I'm going inside the circle, the area of the circle. So it's times pi r squared. And I picked this problem again because I'm still nervous when it says in terms of pi, what the heck you're doing in your calculator. Just, yes, correct. But just right now, put the darn thing in your answer. Whatever's left over, I'm going to multiply with a fraction template. 300 over 360 times 8 squared. And as a fraction, it'll end up being 160 over 3. We okay? Just trying to, I'm picking ones that, require formulas, just show you how many are going to end up coming here. Oh, yeah, we got to finish it on this one. What's up, Mike?
How did you get 165? I'm at 300 over 360 times 64 pounds.
No pi, though.
What?
No, I'm doing 300 over 360 times 64.
Oh, okay. You just multiply.
Right? Because look, take the pi out,
Yeah.
multiply with 300 over 360 times 64. Turn it back to a fraction. Okay. All right, let's finish this on the old partitions. Number 20. Point Q in between M and N, such that it's a ratio of 2 to 3. All right, let's talk about the 2 to 3 real quick. How many parts am I breaking this up into? 5 congruent parts. Anybody want to lead the way here? Start with the x coordinate. The distance between the x coordinates?
3 actually. 3 to 8.
It is 3 to 8, yep. And that's a distance of what? 5, okay. Now here's where we get a little crazy. What do I do with that 5, the distance of 5? I got to divide it up in the 5 congruent parts, right? So I'm going to take the 5, divide it by 5.
And then you multiply times 2.
Why multiply by 2? Because I'm going 2 to 3. So not only do I need to go once, I need to go twice. So yep. So 1 times 2 is 2. Now what do I do with that one?
You have to add 3 plus
Where did I start, guys?
3.
I started at 3, and this tells me this 2 says go 2 to the right. So where do you end up on the x-axis? 5. That still doesn't help me because I have 2 answers that have 5 in it. And then what about your y-coordinate? We're going to do the same procedure just with a different set of numbers. So 5 to negative 5. That's how many units? 10. Cut it up into fives, right? So that'll be 2. What do you want to do with that 2? Don't stop.
Multiply times 3.
It's always the same. The 3, Cam, the 3 is if I started from N going to M, going that way, okay? I always multiply by that first number, which is 4. And what am I adding to 4? 5, yep. But, whoa, be careful. Hey, you're going from 5 to -5. You going up or down? Down, right? Yeah, okay, go ahead. Now, could you just go at the beginning and say that's -10 and carry that negative all the way down? Sure. That's another way as well. Okay? So my final coordinate here, 5, 1. All right? Okay. I'm nervous, but I think you guys can handle having it on Monday. Remember, you don't need to remember any volume formulas. You'll have your reference sheet, but you need the surface area ones.